India is sprinting toward 500 gigawatts of non-fossil fuel capacity by 2030. To get there, we're rapidly covering our expanding cityscapes with pristine solar panels. At a glance, this localized power generation looks like a perfect environmental solution. But this green image hides a massive structural vulnerability resting on our roofs. Understanding the true cost of this technology requires tracing the physical panel back to its origin. Every module represents a global supply chain rooted in raw material extraction and heavy industrial processing. This diagram reveals the scale of geographic concentration. Today, China controls over 80% of global solar manufacturing capacity, and an astonishing 97% of all silicon wafer production. This extreme concentration creates a fragile single point of failure. It means our clean energy transition currently relies on energy-intensive polysilicon refining, an upstream process powered by coal in facilities far removed from the urban centers they serve. India launched aggressive interventions to secure domestic energy sovereignty. Through the Production-Linked Incentive, or PLI scheme, the government allocated 24,000 crore rupees to subsidize the manufacturing of solar components. These protectionist measures yielded fast results. Between 2021 and 2026, domestic module assembly capacity surged from 8 gigawatts to over 170 gigawatts, drastically reducing the need for foreign imports. However, this rapid growth created a module glut. India scaled its assembly factories so quickly that they outpaced the supply of raw materials needed to keep the lines running. While we have mastered the final assembly, we still lack the immense capital and specialized high-tech workforce required to build upstream polysilicon and wafer facilities. Until India can produce its own raw silicon wafers, domestic downstream assembly alone cannot provide true energy independence. Scaling to 500 gigawatts presents a physical challenge. Relying solely on massive utility-scale solar parks to meet India's mid-century goals would require up to 93 million hectares of land. This massive footprint creates a direct conflict with agriculture, which occupies almost 60% of the nation's land. Large-scale land grabs for energy generation threaten long-term food security. Decentralized rooftop schemes like PM Surya Ghar offer a solution. By generating power at the point of consumption, they preserve terrestrial land and eliminate the 5 to 10% energy loss typical of long-distance transmission. India is also exploring physical coexistence through agrivoltaics and floating solar. These models allow panels to sit above active crops or reservoirs, sharing space rather than competing for it. For India, a sustainable transition must be flexible and decentralized. Attempting to brute force the energy goals through massive land acquisitions will only lead to social and ecological stalling. To bypass the existing silicon monopoly, Indian researchers are developing perovskite silicon tandem solar cells. This architecture stacks a specialized perovskite layer on top of a traditional silicon cell. This dual-layer structure allows the panel to absorb a much wider spectrum of sunlight than silicon alone. These cells recently achieved a certified efficiency record of 34.85%. Because perovskites are also lightweight and flexible, they can be integrated into curved architectural surfaces in smart cities. But high-efficiency panels require a functional grid. Currently, India's physical transmission networks are failing to keep pace with our rapid renewable energy installations. Over 44 gigawatts of renewable capacity is currently stranded and unusable due to bureaucratic delays and unsigned agreements with local distribution companies. Investing billions in next-generation panel efficiency provides no benefit if the physical downstream infrastructure cannot absorb or distribute the power. Every piece of hardware we deploy today has a strict expiration date. After 25 to 30 years, these panels reach the end of their lives. This chart tracks the projected exponential growth of solar waste. By 2050, decommissioned panels will account for a staggering 12% of all municipal electronic waste. Mismanaged decommissioned panels leach toxic heavy metals like lead and cadmium into the soil and groundwater, presenting a severe environmental threat. The current market discourages safe disposal. Because separating the laminated glass from valuable metals is mechanically difficult, recycling a single panel costs $45, while dumping it in a landfill costs just $2. Without strict end-of-life regulations and government subsidies for recycling technologies, This green energy transition will ironically engineer a massive toxic pollution crisis. The rooftop solar panel is simultaneously a vital tool for local decarbonization and a complex monopolized liability. Achieving true sustainability requires winning on three fronts: breaking upstream material bottlenecks, accelerating decentralized tandem cell research, and fixing broken solar recycling economics. Secure energy sovereignty demands absolute control over the physical hardware lifecycle, extending far beyond the simple count of gigawatts added to the grid. Solar power only fulfills its clean promise when transformed into a closed, circular system, stretching from the raw material mine back to the recycling bin.